Hello, this is the presentation of Team 2 titled as Energy Flexibility Analysis of a Near Net Zero Energy Institutional Building in Quebec. The growing interest in net zero energy buildings as a promising approach to address efficiency in building sector mandates the need for accurate models for prediction of consumption and generation. Due to distinctive operation schedule, institutional buildings have different consumption patterns compared to the other types of buildings. Therefore, there is a need to extract and interpret the dominant energy patterns of such buildings. The Varennes library, as the first Canadian near net zero energy library, is investigated in this project as a case study for the following objectives. Our objectives are to find and interpret the dominant electricity consumption and on-site electricity generation patterns based on measured data, to conduct a correlation analysis for selection of the most appropriate features for predictive models, to forecast the HVAC electricity consumption, to forecast the on-site solar electricity generation, and finally to forecast self-generation and self-consumption as measures of building energy flexibility.
As our first objective, we will use available historical data to extract the prevalent HVAC electricity consumption and on-site electricity production patterns using K-means clustering. Since Varennes library works on a specific schedule and due to the intermittent nature of renewable sources, using clustering techniques helps to find consumption and generation profiles to have a better understanding of building performance in different days of week and weather conditions. One of the preliminary steps before applying machine learning techniques is finding the best attributes or features for your model. This work is done through correlation matrix using RapidMiner and comparing Pearson correlation coefficient to select the highly correlated attributes for further use in the following predictive objectives.
After doing correlation analysis and feature selection, we are going to focus on forecasting HVAC electricity consumption. For this, first we apply different linear regression models including multiple linear regression, support vector machine, and neural network for predicting HVAC electricity consumption. Then evaluating performance of forecasting with different models for summer and winter. And finally, comparing the methods based on squared correlation and root mean square error and selecting the best prediction model. Another objective is forecasting the on-site solar electricity generation. In this case, we follow the same step as HVAC electricity consumption by considering features related to solar electricity generation. By selecting the best model, in the next step we will quantify energy flexibility. Energy flexibility is defined as the ability of a building to manage its demand and on-site generation according to local climate conditions, user needs, and utility grid requirements. For this, we will calculate two energy flexibility measures, including self-generation, which is the proportion of electrical demand met by on-site generation, and self-consumption, which is the proportion of on-site generation consumed by building.
The Varennes library datasets comprise of a heating season and a cooling season. They can be obtained from this link. For the initial exploratory data analysis, we have this table of attributes. We decided to omit the schedule-based attributes such as date and time, cons no heating, cons no cooling, and light cons. We also decided to omit the attributes which form an equation with other attributes such as cons. Furthermore, GHI is already taking into consideration DNI and DHI. Therefore, we decide to eliminate these two. For the visual descriptive, we decided to inspect the linearity between the attributes via Pearson correlation matrix. This one is in the form of a heat map. For the upcoming steps, we will modify the developed linear regression models. We will evaluate and compare the predictive model's performance. Finally, we will adopt the validated model to quantify self-consumption and self-generation of the building as measures of energy flexibility.